Consider this Math Olympiad question on exponential equations. 3 raised to the x plus 9 raised to the x is equal to 27 raised to the x. What is the value of x? So if you want to pause the video, feel free to do so and solve this problem. So let's begin. Notice that 3, 9, and 27, they're multiples of 3. In fact, you could break it down into base 3. 9 is 3 times 3, or 3 squared. 27 is 3 times 3 times 3, or 3 to the third power. So we can write 9 as 3 squared, and we can write 27 as 3 to the third. Now, what should we do next? Whenever you raise an exponent to another exponent, you can multiply the two exponents. So a to the m raised to the n is a raised to the m times n. You can also reverse it. M times n is the same as n times m, or 5 times 3 is the same as 3 times 5. So what I'm going to do is I'm going to reverse the 2 with the x and the 3 with the x. So 3 squared raised to the x is equivalent to 3 raised to the x squared. And we could do the same thing for the other one. Now notice that we have a common base, 3 raised to the x. What we can do at this point is we can do a substitution. We could pick any letter, A, B, C, D, E, F, G. Let's use the last letter of the alphabet, Z. So we're going to say that Z, we're going to make it equal to 3 raised to the x. So now we could substitute 3 to the x with Z. So we're going to have Z plus Z squared is equal to Z to the third power. Now, in order to solve for Z, I'm going to take these two and move it to the other side. So on the left, I'm going to have 0. On the right, it's going to be Z to the third minus Z squared minus Z. So now what we can do is we can factor Z. So we'll be left with Z squared minus Z minus 1. Now we could break this up into two factors using the zero product property. 0 times anything is 0. So if n of one of these factors is equal to 0, the whole thing is 0. So we could set each of those factors equal to 0. So we have Z is equal to 0, and Z squared minus Z minus 1 is equal to 0. So this is one solution for Z. To get the other one, we need to use the quadratic formula. Z is going to be equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. A is the number in front of z squared, which is 1. B is the number in front of z, which is negative 1. And c is also negative 1. So this is going to be negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1 divided by 2a, or 2 times 1. Negative times negative 1 is positive 1. Negative 1 squared is positive 1 as well. And then negative 4 times 1 times negative 1, that's positive 4. One plus 4 is 5, and so we get that, which we can write it as two separate answers. So Z is 1 plus the square root of 5 over 2, which is approximately 1.618, which turns out to be the golden ratio in the Fibonacci sequence. And the other one is z is 1 minus the square root of 5 over 2, which is approximately 0.618. Now I want to take a minute to show you how you can access my final exam videos for those of you who are preparing for your final exams. So if you type in organic chemistry tutor in the YouTube search bar, it's going to take you to what you see here. And if you click on this, this will take you to my channel. And then if you go to the community tab, you'll see a list of the exam videos that I have available. So pre-algebra, algebra, geometry, trig, pre-calc, calc 1, calc 2, physics, a lot of physics, general chemistry, and even organic chem. So let's say, for instance, you go to my physics final exam video. This video has about 40 questions, but if you check the description, I have a 6-hour version which has 100 questions. So this video is the first 2 hours out of the entire 6-hour video for this particular final exam review. So for those of you who have the exams coming up, you may want to get an early start on these videos. So feel free to check out the community tab when you get a chance. Now for those of you who might be interested in seeing the video that I created on the Fibonacci sequence, just go to the YouTube search bar, type in Fibonacci Sequence Organic Chemistry Tutor, and the video should show up in the search results. So right now, we have the 3 values of z. Now we need to calculate the value of x. So first, we can replace z with what we have here. So if z is equal to 3 raised to the x, we have 0 is equal to 3 to the x. So what is the value of x? 3 to the what power will give us 0? The answer is nothing. There's nothing that we can plug into x that will give us 0. Maybe negative infinity, but that's not really a number. If you plug in a large number, let's say a large negative number, 3 to the negative 1000, it won't give you exactly 0, but something very close to 0. It may be like 0.000000, goes on for a long time, and then 1. So this is just not going to happen. Now you could describe it as a limit. The limit as x approaches negative infinity for 3 to the x, this will become 0, but it's not really an exact number. Now one way in which you could try to solve this is by taking logs. If you take the log of both sides, log 3 raised, log 3 raised to the x is equal to log 0. This is not going to work either. If you type in log 0, the calculator will give you an error. So there's not an x value that, or at least an exact x value that we can plug in to get 0. We can get close to it when x goes to negative infinity, but we can't really get a 0. So the only other thing we can do is use these values. And I'm going to need some space for this. I'm going to rewrite the answers for z, just to get some space here. So let's start with the first one. Let's replace z with 1 plus the square root of 5 over 2. And set it equal to 3 to the x. To get x, we need to take the log of both sides. And then what we can do is move this exponent to the front using properties of logs. And we'll get x log 3. And then to get x by itself, we need to divide both sides by log 3. Now, if we want to, we could simplify this using the change of base formula. Log AB is log B over log A with a new base C. We haven't defined what this base is, but it really doesn't matter. It could be anything. So using the change of base formula going back in this direction, we can rewrite this expression like this. So we can write it as a single log, base 3, and then whatever we have here. 1 plus the square root of 5 over 2. So that's equal to the value of x. But that's using the positive value of z. If we were to use the negative one, where we had 1 minus root 5 over 2, the other answer for x would be log base 3, 1 plus the square root of 5 over 2. Now let's see if we have the right answer. So what I'm going to do is I'm going to get the decimal value of x, at least for one of them. So if you type in log, parentheses 1 plus square root 5, close parentheses, divided by 2, close again, and then divide that by log 3, you should get an x value of 0.438. It's 0.4380178, but this should be good enough. So let's plug this in. Let's see if this is going to work. Three raised to the 0.438, that's 1.618, interestingly. 9 raised to the 0.438, that's 2.618 if you round it. And 27 raised to the 0.438, that's 4.236. 1.618 plus 2.618 gives us 4.236. So this is an accurate answer. Now the other answer, and this should be a minus instead of a plus. Will the other answer work? What would you say? This answer should not work. The reason being is we can't have a negative number inside log. So if you were to type it in, you'll get an error. So we can eliminate this answer. You can't have a 0 or a negative number inside of log. So those two values of z should be eliminated. Therefore, this is the only one that's going to work, 0.438. So that's the rounded answer, but this is the exact answer. So that's how you can solve an exponential equation that looks like that. So if you go to my website, video-tutor.net, it's going to take you to this page where you can check out my ebook on how to pass math and science classes, or if you want to get the first chapter free, you can join my email list. So feel free to take a look at this when you get a chance if you're interested. But now let's get back to the video. Now let's try another problem. How would you solve this exponential equation? If you're taking College Algebra, you're going to learn exponential equations and logarithms. But anytime you want to solve a variable in the exponent position, you could use logarithms to do that. So what I would do in this problem is I would take the log of both sides. So we have log of 5 raised to the x plus 6, and that's equal to log of 6 raised to the x plus 5. Log a raised to the x is equal to x log a. So that's one of the properties of logs that you just have to know. It is what it is. So anytime you have an exponent, log allows you to move the exponent to the front. So we're going to use that property, and we're going to take this entire exponent, x plus 6, move it to the front. And we're going to do the same thing with x plus 5. So now we have x plus 6 log 5 is equal to x plus 5 log 6. Our goal is to isolate x. But in order for us to do that, we need to distribute log 5 and log 6. So here we're going to have x log 5 plus 6 log 5. And then this is going to equal x log 6 plus 5 log 6. Now, I'm going to subtract both sides by x log 5. And I'm going to subtract both sides by 5 log 6. So these will cancel. On the left, we have 6 log 5 minus 5 log 6, and that's going to equal x log 6 minus x log 5. Now, on the right side, we can factor out an x. If we do so, we're going to be left with log 6 minus log 5. And now let's divide by that. Whatever you do to the right side, you must also do to the left side to make sure the equation remains balanced in value. So now what we have on the left is our answer, and that is 6 log 5 minus 5 log 6 over log 6 minus log 5. So that is the exact value of x. Now, if you want to get the decimal value, make sure to put this in parentheses when you plug it in your calculator. So let's go ahead and do that. So 6 log 5 minus 5 log 6. As a decimal, that's 0.30306. Then if you divide that by log 6 minus log 5, you should get 3.8275. Now, if you're not getting the right answer in your calculator, it's probably because you might have forgotten to put the parentheses. So that's why it's important. Otherwise, you can get a completely different answer. But now let's make sure this answer is correct. So we're going to plug it in. So I'm going to plug it into here. If we add 6 to this number, x plus 6, that's going to be 9.8275. Here we have x plus 5, so I'm going to add 5 to that number. So this is going to be 6 raised to the 8.8275. 5 raised to the 9.8275, that's a big number, 7398228. And then 6 raised to the 8.8275, it's 7398270 if you round it to the whole number. Now, this is not exactly the same, but they're relatively close in value because we're dealing with such large numbers that it's 99.9% accurate. Now, of course, if we were to plug in the exact value, these two will be exactly the same. So right now we could say they're approximately the same due to the fact that we've rounded. So this is a good estimation of the answer, but this right here is the exact answer. So that's how you can solve this particular exponential equation. It's by using logarithms.